Hello. Now we are going to talk extensively about the difference quotient, which is a really important topic for us, especially any of my students that are moving into Calc 1, Calc 2, Calc 3, or even just brief Calc. You're going to see something that looks like this a whole lot. Now, the difference quotient is related to the derivative, and the derivative represents rate of change, which kind of makes us think of slope. So the difference quotient is related to the idea of slope. For our purposes, we are really just focused on being able to plug x plus h in, subtract two functions, and divide and simplify. So we really want to make sure that we can focus on these algebraic operations and that we know how to manipulate them so that we'll feel comfortable when we start dealing with the definition of a derivative in our calculus class. So in order to find the difference quotient, we have three steps. The first thing we want to do is to find this f of x plus h piece. So we want to find f of x plus h first. Once we know what f of x plus h is, well, we will always be given our f of x function. So this f of x is always going to be given. And we're going to plug that in, simplify, that's going to be our difference quotient. I think the easiest way for us to do this will be to look at an example. So the example that we're going to work with here is given this function f of x equals 2x minus 3, f of x, we're going to find and simplify our difference quotient expression. So the first thing we need is we need to know what f of x plus h is. So that means we're taking the function and instead of x, we're going to write x plus h. We are plugging the expression x plus h into the variable x. And what that looks like is 2 times, instead of x, we now have x plus h, making sure you use your parentheses, minus 3. Distributing, that's 2x plus 2h minus 3, the 2 does not distribute to that 3. So now we know what f of x plus h is. We are also given f of x. So setting this up, my setup here is we're going to have f of x plus h minus f of x, and then all of this is divided by h. So I was given f of x, and I just found f of x plus h. What this looks like is 2x plus 2h minus 3, I'll go ahead and use parentheses to keep that grouped, minus my original function, 2x minus 3, all of which needs to be divided by h. So that's my setup. That's step 2. My third step here is just to simplify. So in this situation, I'm going to go ahead and distribute that negative. And that gives me 2x plus 2h minus 3. I have minus 2x plus 3, all of which is divided by h. Now you'll notice, and almost every time you do this problem, the second expression should cancel. So I have 2x minus 2x, those are both gone. Negative 3 plus 3, that sums to 0, those are gone. This simplifies to 2h over h, which simplifies down to 2. So 2 is our difference quotient. All right, and that's a linear difference quotient. Now, I know I'm talking a little bit ahead of where you are in your notes, but thinking about our given function, some of you may recognize that 2, this coefficient on x, is our slope. And I told you that this difference quotient is related to the derivative, which is average or instantaneous rate of change, and that gives us our slope. Rate of change is slope. So it makes sense that my difference quotient is 2 for this linear function. So again, more functions to come, but we really just wanted to make sure that we understand how to set up and simplify this difference quotient. So we'll have two other videos. We'll have one with a quadratic difference quotient and then one example with a rational difference quotient. As always, feel free to email me if you have any questions or concerns because I am here to help. Good luck.